Hello. In the lecture, the main focus of the lecture is a tropical projective torus. Why we should run a tropical projective torus? The background is the previous lecture, based on the previous lecture. In the previous lecture, I explained two ways to estimate between two probability density functions. One is Kullback-Leibel divergence, and the other is P-Wasserstein metric or P-Wasserstein distance. But if you see the formula, P-Wasserstein distance, that is so abstract. Nevertheless, some people say that is orthomover distance or optimal transportation. Why? If we see this formula, this relation, it is quite difficult to catch why this is related to optimal transportation. However, if we translate P-Wasserstein distance, the concept of P-Wasserstein metric, to the language in the tropical torus world, namely, the language in the tropical projective torus, we can understand why this is related to optimal transportation. Okay, then what is here? The name is tropical projective torus. Why this is torus? Why this name has projective? Why this name is contains tropical? In this lecture, I will explain everything of the tropical projective torus, and if we understand this, we try to translate the P-Wasserstein distance into language of tropical torus. Okay, let's go ahead. Let's see the projective torus. The origin of the projective torus is the so-called art perspective, like this, to describe the picture if the distance is longer and longer. Some people, that point is a vanishing point. Okay. Tropical projective geometry in the before to 20th century, in my background, the concept of the projective geometry is one of the most important part of the geometry, like arithmetic. But at the middle of the 20th century, that is absorbed in part of algebraic geometry. So if we try to study what is the concept of the projective space, you should learn the concept of algebraic geometry. So in detail, projective space, affine space. Okay. So anyway, I explain what is the projective space. The concept. Okay? If we take 2 points, x1, n plus 1 coordinate. But we can, if we pick the point must exclude 0 point, 0 vector, 0, 0, 0, n minus n plus 1 coordinate. Then give a relation. There exists also non-zero element lambda such that y is expressed lambda times x. Then that satisfies equivalence relation on Rn plus 1, 0. We can define equivalent class is denoted by x as a representation. Bracket means representation, xn plus 1, and its element Rn plus 1 lambda defined by R P n. That is, we call the space is a projective. In that case, the every element or real number, real projective plane. Of course, if we change the complex plane, we denote it by CPN. Okay. That is the concept of the real projective plane. We call that guys real projective plane. That means if we find some point, roughly speaking, 2 points, I take 2 points, then if we find a line which passes through the origin, okay, we can 2 points share the same line. We can view these 2 points as same point. Okay, that point and that point is regarded as the same point. So if the point in the line is regarded as the same point, that is concept of the projective space. Okay. So in a plane, R2, if a 2 point is given, x1, x2, or y1, y2, and if we find the line like this, then express that point as a vector sense. There exists lambda such that like this. Okay, then we can regard it the point as same. Okay, in that case, if we point this coordinate, okay, that guy is expressed by x1, comma x2, like bracket. But important observation, if we take x1, xn, right? In that case, I will delete the small bracket. Okay, that is better. But and its coordinate expressed semicolon. Oops, I don't know. Okay. Important observation is that if we consider the coordinate like this, in the RPN, at least one of xi is non-zero. That means that every coordinate of the element is not non-zero. So 0, 0, 0 is impossible, because we can define the definition of the projective space. So without loss of generality, if xn is one of the non-zero component, clearly we can find non-zero element. But if that guy is really non-zero number, we can divide by the coordinate xn minus x, and the last coordinate is xn divided by xn, that is just 1. Okay. In that case, because this relation with any projective coordinate is given, we can do this process. Okay. Then that number 1 does not have a meaning. Just so-called dummy variable. So if we study the algebraic geometry, where in projective space is written as just affine sense like this. In fact, to discuss this relation, we must discuss about the topology, Zariski topology, structure, and so on. So complicated. So, important point is that we can regard one coordinate as a dummy. Okay, then that coordinate is total n coordinates. So that is the reason why we can, this equivalent relation is RPn instead of RPn plus 1. So in fact, the dimension of projective space RPn is n. But warning, this is if we say this expression, we should think about my speaking. Dimension. What is dimension? In a linear algebra, dimension is the number of the vector space. Number of the basis, okay? Number of the basis. And to define a basis, this space must be vector space. But projective space is not a vector space. As we see my Instagram scene, you can check this relation, because many reasons why this guy does not a big vector space. The reason is, one of the main reasons is that the addition of the two coordinates does not well defined. So that is not a vector space. So so it's very dangerous to say about dimension in the sense of the linear algebra. In that case, the dimension of the space is in the space affine space sense the concept of the affine space. In the affine space, dimension is defined by chain. That is concept of the algebraic geometric concept. Okay. So the anyway, that is dimension is n. Oh, sorry. N, as you see, but you should worry about. You should think about the dimension is not a concept of the linear algebra, but the algebraic geometry. Okay.